Okay, so let's go ahead and get started with the derivative of trig functions. So let's see if we can graphically solve the derivative of y is equal to sine x. This is y is equal to sine x. So I'm going to try and take the derivative of this. And the derivative of this is nothing more than the slope of the tangent line. So the tangent line starts at a number, and it goes like this. And then as it comes here, what is the slope of the tangent line here? You can't see. What is the slope of the tangent line here?
0.
0, right? So it goes down here, and then it comes down here, and it goes down to 0 again here. So you have 0 here, you'll have 0 here. So every time there's a peak or a valley in the trig function, you're going to get a situation where the derivative is equal to 0. So whatever this function is, I know it's going to have, the derivative is going to have zeros at these points. Okay? So the derivative here, the slope, starts at something, gets smaller and smaller and smaller and smaller. Although it's still positive, it goes to 0, right? So it's going to go from here, and it's going to go like this, under 0, right? And then from here, it becomes slightly negative, more negative, more negative, more negative, more negative. And then it's going to even out, to bottom out here, become less negative, less negative, less negative to 0. Okay? So go like this, negative, negative, bottom out, come back up like this. Right? Same thing here. Now we're going to go positive, go slight positive, positive, positive. And then peak up here, and then go less positive, less positive, less positive to 0. Right? Same thing here. So what does this graph look like here down here?
Cosine.
Cosine. So the y prime of this is going to be equal to cosine x. So we've graphically kind of proven that the derivative of sine x is cosine x. Okay? All right. So we can actually do the same exercise with cosine, right? Now let's see if we can do it with cosine. So cosine x starts from the top here, goes like this. So now this is y is equal to cosine x. Let's go and take the derivative. So I know at this point, I'm going to have a 0. Or if there's a peak or a valley, it's going to be 0 because the slope of the tangent line is going to be 0. I know these are zeros. I start from 0, and I'm going to go negative. Less negative, less negative, more negative, more negative, more negative, more negative. Play bottom out here. Then I'm going to go less negative, less negative, less negative to 0. So this is where I bottom out. So I'm going to go like this. From here, I go positive, more little positive, more little, little, more positive, more positive. I'm going to top out here and then go less positive, less positive, less positive to 0. Same thing here, I'm going to go negative, little negative, more negative, more negative, more negative, bottom out here, and then less negative, less negative, less negative, back to 0. It's like that. Okay, so this is not sine, right? Because sine would look like this, right? So this is going to be what? Actually, negative sine x. Can you see that? Can you see that this is negative sine x? All right. So what did we learn? We learned that sine x, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So we have learned that the derivative of sine x is equal to cosine x. Then the derivative of cosine x is equal to negative sine x. Okay? All right, so that is what we learned. And if you go and look at that, if you go to page 144, there's a green box that says the derivative of sine x is equal to cosine x. Then it also says, and then there's another one there that says the derivative of cosine x is negative sine x. Okay? All right, so let's see if we can go ahead and do example number 1. Now that we know this. Example number 1 says a y is equal to x squared sine x. Okay, so I'm taking the derivative of this. So this is f, this is g, so it's a product rule. If we do the product rule, so I can take the derivative of this guy, which is 2x, and then just bring this guy over, sine x plus, I keep this guy, and then I take the derivative of sine x, which is cosine x. So that's your answer. Okay. B, what do we have here? U is equal to cosine x over 1 minus sine x, 1 minus sine x. So let's go ahead and now take the derivative of this. If I take the derivative of this, I get what? What am I going to use? How am I going to do this? Natalie, what rule am I going to use? Natalie, are you there? We have no Natalie. Never mind. I'm calling somebody who's not here. Kayla.
The quotient rule.
The quotient rule, right? So it's going to be 1 minus sine x squared. I'm going to square that. And then I'm going to get what? Low d high. It's going to be low d high. So I have to take the derivative of this guy, which is negative sine x minus high cosine x d low. I have to take the derivative of the bottom. So it's going to be what? Minus cosine x, right? So I'm going to get what? I'm going to get minus sine x plus sine squared x plus cosine squared x over 1 minus sine x squared. Notice that sine x squared plus cosine x squared, that's 1. So on the top, I'm going to get minus sine x plus 1. Over here, I have 1 minus sine x squared. Top and bottom are the same, but different powers, right? So one of these goes away with this. So you're going to end up with 1 minus sine x over 1. And okay, that's it. All right? So that's how you use the trig function derivatives, okay? That was example 1. Let's go to example number 2. In example number 2, it says, the way derivative is that. What is the velocity and acceleration at time t? Okay, so I have s is equal to 5 cosine t. Cosine and 5 cosine t This is example 2. This is it. So I want to find what? The velocity and acceleration. So the velocity is s prime. So it's a derivative of this guy. I take the derivative of cosine t, I negative sine t. So it's going to be negative 5 sine t. That's a t. Better than that. Sine t. A is equal to the derivative of velocity. So I can now take the derivative of this. So I'm going to get negative 5 sine t. The derivative of sine t is cosine t. Okay, so that's it. Okay, now on the bottom of page 145, there's a thing called jerk. And jerk is what jerk is called J. Jerk is nothing more than the derivative of the acceleration. So in other words, as you accelerate, how smoothly or jerkily, or whether it's smooth or jerkily, you accelerate. Okay, so that's what that is, because it's the change in acceleration. Okay, so if I want to do the jerk here, what would it be? I'd have to take the derivative of this guy, which would be negative sine t. Negative and negative cancels out, so I get 5 sine t. Okay, so that's what jerk is. Okay, and let's stop right there. And then we'll come back and do the derivatives of the other basic trig functions. We'll do that later on, the second half, okay? So let's go ahead and get started on the home.